So here's something that I just simply can't emphasize enough, and that is that functions are really, really important, both in computer science and mathematics. And just to kind of show you all the places these things show up, um, I'm going to show you many different ways to define functions that you're likely to run across. Okay, they have lots of different notations, and they makes perfect sense in each different setting. I won't necessarily argue for one notation over the other. I mean, that's largely just a matter of taste. Okay, but let's start with this. Here we have a function called max2. I'm calling it max2 because it has two arguments, x and y. Okay, and I'm defining it by cases. So this is one of the standard ways of defining functions. Yeah, the function f of x, in this case f of x and y, is equal to, and then cases. So the value of this is equal to x if x is greater than y, and is y if y is greater or equal to x. So what I have is the maximum of x and y. Okay. Notice that these cases are disjoint, right? That's what lets me do this, because what I'm really doing is taking the union of two unnamed functions. Okay. All right. Here's another definition of that same function, right? It's the same mathematical concept, but in this case, what I'm doing is I'm writing it in Python. Okay, and in Python, it's got its quirks. So we say define def. We have to use a colon. That's ubiquitous in Python. And if x is greater than y, here's another colon. We return x, otherwise we return y. That's actually a function, a Python function that does the same thing as does definition by cases. And you see that the cases I've got to turn into an if statement. So right here, this is, I believe this was case 1. And right there this is case 2. Right? In that function that was done by cases. Right? So we had x if x is greater than y, y if x is less than or equal to y, right? By the way, this is often just said otherwise. Okay, but the point is that a definition by cases is simply a definition using an if statement, where the if statement lets me select what case am I in. So this is case 1, this is case 2, right? And then once I know what case I'm in, then I just simply have the value that I'm supposed to return. Okay, same function, it's just different syntax. All right, here is another way of doing it. I'm going to take back what I said about not judging syntaxes. This is absolutely horrible. This is C, and this is the way that we build functions using the what's known as the preprocessor. Okay. The reason that we would use the preprocessor is that this is the way in C to write functions that are inline functions, as opposed to functions that actually require jumping out of your location, going to another place, and then returning. So this is very efficient, but it's also not very readable, is it? So that's just a bad notation. But just to show you, here in C we have different ways. This is the very famous ternary operator. That's what they call it in C. It's because it's the only ternary operator. But a better word would have been conditional operator, right? Which means an if statement. Okay, except it's not a statement, it's an operator. Okay, nice. Now let's see what other kind of languages we have. Look, this is C++. Okay, so in C++ we can write the exact same function. We can do inline, which is good, so that is efficient. And notice that it is again, I'm in case 1, I'm in case 2, and we do that by having one if statement, right? If there's 2 cases, I need one if statement to differentiate it. If there's 3 cases, I'll need 2 if statements. If there's 4 cases, I'll need 3 if statements, and so on, right? Makes sense. Okay, so do any other syntaxes? Oh my God, this is actually the exact same thing. This is Java, okay? And in Java, you can't have a function that's not part of a class. So here's my function. And it needs to live inside the context of a class. That's why it's so much. But anyway, when we come back down to it, we have case 1, case 2, and we have the one if, right? So it's very, very similar, right? It's the exact same function, but it simply takes more keystrokes because it's because it's Java. Okay. All right. Here's another definition. Brownie points if you figure out what language this is. It's actually MATLAB. Okay. And MATLAB has some quirky syntaxes. I find this thing here very quirky. Max m equals max2. And then what happens is instead of returning things, you assign m, okay? And that's how he knows what to, quote, return. But again, we have case 1, case 2, right? This is the same definition by cases with one if statement to differentiate between the cases. Okay, this is not a programming language, okay? This is simply logic. And what I'm saying is I'm defining max2, okay? And I'm defining by axioms. Okay. So before, what I did was f of x is equal to by cases. Okay. Now I'm doing it by axioms. So I'm going to give you two axioms that are both true and that combined those axioms define what it means to be max, right? So whenever x is greater than y, then max2 has to be equal to x. If x is not greater than y, it's actually the same thing as saying that x is less than or equal to y or that y is greater than or equal to x. I simply wrote it this way to make it clear that my two cases were disjoint, okay? But anyway, when x is not greater than y, then max x2 of y is equal, max2 of x and y is just equal to y, right? You see that this is very similar to the definition by cases, except I'm simply giving you more than one equation, as opposed to giving you one equation with many right-hand sides. That's it. That's the only difference between these. Okay, now we started working with ACL2, right? And this is the definition in Lisp, which is a programming language. ACL2, we're using ACL2S, and this is Lisp minus the, I'm just going to say the dirty stuff, okay? Okay, and plus a logic system. Okay, that's basically what ACL2 is. Anyway, what you'll find is that there's an if statement, right? And this is the way that we do ifs in Lisp. We say if we have a condition, and then we have the then case, and then we have the else. Okay, now this thing is actually not a statement. Instead, it is a function. Okay, and so what we have is if of x, y, z, right? The way to think about this is as y if x, z otherwise. And here I'm simply defining that function using by cases. Okay, but this is actually closer. It's more like ternary operator in C. And by the way, in C++, of course. Okay, and Java, right? You know, C invented it, but all the other languages picked it up. So this is the colon that. So we have condition, then else, right? You know, that syntax. That's what this is. All right. So notice again that we have a number 1 case and a number 2 case, and we have one condition. So it's just like the Python, just like the C, just like C++, just like Java, right? We simply have two cases because we're doing definition by cases and there were 2 rows. We have enough if statements to be able to figure out what row we're in. That's just one if statement because there's only 2 cases. And then the values to give in those.